Hi everyone, welcome to AI Crack channel. This is Akash Kumar and today we'll be studying probability lecture 1. So in this lecture we'll be talking about certain basic definitions and also we'll be doing problems related to PNC, which are basically part of probability lecture only. Now let's talk about the basic definitions. We have seen these definitions from 10th class, but we'll just reiterate it once again, to get it done. Now, what is sample space? Basically, sample space is a set of all possible outcomes of a random experiment. What can be a random experiment? Basically, a coin is there having heads and tails, unbiased coin is there having heads and tails. If you toss it, then you'll be getting either heads or tails. So basically, these are the two events over here. So these are the two possible outcomes. It can come out to be H, it can come out to be tail, right? Now, if you toss two coins, then probably you'll be getting HT, TH, HH or TT. So an event is a subset of a sample space. So all these possible outcomes are the entire set of all these possible outcomes is called a sample space, and a subset of this particular set, entire set sample space is called as an event, right? Now, basically, how does that look into a question? How does that fit into a question? So that would mean an event would be tails coming first and heads coming afterwards. So that can be called as an event, right? Or some simple subset of that sample space. Now we have this definition called the complement of an event A. With respect to a sample space S is the set of all elements of S which are not in A. For example, if I'm talking about tails coming first and head after that heads is coming. So this is one event. Now complement of this event would be of this not happening, right? So that would be this one, that would be this one, and that would be this one. So basically, if I talk about the complement, that would be represented by A dash or A bar or AC, whatever you want to prefer. So A A dash plus the remaining elements would combine the entire sample space. So this and the elements or the events which are not a part of this particular event, uh, summation of both of them would be the entire sample space, right? That's what we mean by complement. Now, what is the classical definition of probability? Basically, that means number of favorable outcomes divided by total number of outcomes. So, for example, in case of, again, let's take two coins over here. We're getting HH, TT, HT, and TH over here. Now, if I want to find out the probability of heads coming first, in that case, this is the case and this is the case. So, favorable outcomes are 2, and the total number of outcomes are 4. So, we'll be getting the probability as 1 by 2. This we all know, I'm just reiterating once again. Now let's take one example, and these examples are PNC related examples. You might get one of them, you might not get one of them, but the main theory of probability will start from the next lecture. Now, two natural numbers are randomly selected from the set of first 20 natural numbers. Find the probability that their sum is odd, sum is even. Okay. Now we have to select two random numbers from first 20 natural numbers. So the total sample space would be total number of ways to select it, right? So that would be 20C2. And if the sum is odd, sum can be odd when we select one even number and one odd number. Only then sum can be odd. In case of odd plus odd, we'll be getting even. In case of even plus even, we'll be getting even. So in case of sum is odd, we have to take this case even plus odd. So there are 10 numbers in first 20 natural numbers. There are 10 even numbers and 10 odd numbers. So 10C1 dot 10C1, choosing one even number and selecting one odd number, right? So this would be my answer for the A part. Now, if we talk about the second part, sum is even. In that case, that would be E plus E or O plus O, right? So this means the entire sample space still 20C2 only. For E plus E, basically I'm choosing two even numbers out of given 10 even numbers, or I can choose two odd numbers from the given 10 odd numbers, 10C2, right? That would give me 2 times 10C2 divided by 20C2. This would be my answer for B, and this would be my answer for A, right? Now let's talk about this example. A leap year is selected at random. Find the probability that it has 53 Sundays, 53 Sundays and Mondays, 53 Sundays or 53 Mondays. Okay. Now, so if we talk about the weeks over here, because we are talking about Sundays and Mondays, so we should be knowing how many weeks are there, because in one particular week we have one Sunday or one Monday, right? So we know that 52 weeks, at least 52 weeks are there in every year. At least 52 weeks are there. So 52 weeks means we have 364 days. In case of leap year, we have 366 days, right? So we have 364 plus 2. This is the kind of structure we are going to have for the particular year, right? So this is week 1, this is week 2, this is week 3, and we have in the last week 52, and we have 2 spaces left. Now this will have one Sunday, this will have one Sunday, this will have one Sunday, and this will have 52nd Sunday. So we have 52 Sundays at least, or 52 Mondays at least, or 52, any random day would be 52 number minimum, right? Now we have these two possibilities which can define, we can have, if we can have 53 Sundays, or if we can have 53 Sundays or Mondays, right? So how many ways we can fill these two entities, these two gaps over here, these two spaces over here, right? So that can be either Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, or Saturday, Sunday, right? So we can see that we are getting Sunday 2 times over here. So we have two possibilities to get 53 Sundays. So out of these 7 possibilities to fill these two gaps, we have two possibilities, two favorable outcomes in which we'll be getting 53 Sundays. Either it can be Sunday, Monday, then we'll be having these 52 plus this one Sunday, or we can have Saturday, Sunday. In that case, we'll be having 52 Sundays over here and one Sunday from here, right? So 2 by 7 would be the answer, because total number of events would be 7 over here and favorable number of events would be 2. In case of 53 Sundays and Mondays, so that is just one case, right? Sunday and Monday, that would be 1 by 7. In case of 53 Sundays or 53 Mondays, so basically we can include Monday, Tuesday as well, because even if there are not 53 Sundays, there are 53 Mondays. So basically, if we have Sunday, Monday, if we have Monday, Tuesday, if we have Saturday, Sunday, then also it would work fine, and we'll be having 3 by 7. Okay. Now let's look at this example. What is the chance that fourth power of an integer chosen randomly ends in the digit 6? Okay. So you must be knowing that if I multiply 2 raised power, if I do 2 raised power 4, I'll be getting 16. But what if I do 22 raised power 4? What number I'll be getting? I might be getting some big number, but basically I'll be getting in the end, I'll be getting 6, because we have 2 in the end. So that is the thought process we have to use over here. Regardless of whatever the big number is we are having, the end digit is the one which is mattering over here. So end digits can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the 10 end digit numbers, right? Right. So we can directly ignore the odd numbers, because we are not going to get 6 as the end digit in case of odd numbers, right? So we have the remaining choice of 0, 2, 4, 6, and 8. In case of 0, it's going to be 0 only. In case of 2, we saw that it's going to be ending in 6. In case of 4, it's again ending in 6. In case of 6, you can check that it's ending in 6. And even in case of 8, it's going to end in 6, because 8 times 8, 64. We have one more pack of 64. If I multiply 4 and 4, we'll be getting 6 over here, right? You can similarly verify for other numbers as well. And so basically we have 4 possible favorable outcomes over here. That is 4 divided by total number of outcomes are 10, and that would be our answer. That is A. So this lecture was till here only, and that was a pretty short lecture, because that was just the introductory lecture about what are the kind of PNC related problems you can get in probability. And we have got, I think, one problem related to PNC and probability, right? So we might get some similar kind of problems over there, but that's quite, having a lesser chance to get such kind of problems. So that's why I kept it short, and will be soon jumping into the main theory of probability. So let's meet tomorrow. Thanks for watching.